the issues with respect to the purchase of the crops. That is one side of the coin. The other side of the coin being the storage capabilities still has to be raised for the crops, right? So the point of concern is, can we reduce hunger, right? Can we alleviate hunger? So this question is a $1 million question for me, right? Not only for me, but also everyone across the globe. They they can answer to only some extent how to handle the problem of hunger, right? So every day in many of our college canteens, right, we see so many hoardings saying save food, right? And they also show up so many statistics regarding how much amount of food is going waste, right? That those statistics also make us understand, make us feel, oh, this much amount of food is being wasted, right? So that consciousness should take one step further from our side, right? Make us to move one step ahead and treat that problem with the help of technology, right? So this slide will make you clear that how India feed her population, right? We treat our country as mother, right? That's why I am using the word called her. So yes, as you see, 40% of Indian children are malnutritioned. So there is a specific information shown in Madhya Pradesh, right? 2/3 of the children are malnutrition. Right? So India loses 40% of its food in transit. So proper packaging and proper, what you say, the storage in the transferring process, the food transfer process, right? The food supply chain should be very much clear, right? Should be very much, what you say, transparent in terms of the amount of food that has been loaded and the amount of food that has been, uh, what you say, at the destination they are dropped off, right? Then, so this value, the India spending 0.6% of GDP on agriculture will has been increased. Let us say this slide is uh, around 2 years back, right? Slide, but this value has been increased now today. So yet India should, I say should, because I cannot frame policies, but still India should improve its percentage of GDP on agriculture. Right. So as you see, uh, if I, let us say, if I turn my side towards technology, so can technology be ever helpful to handle the problems that we have discussed, right? So you see on the slide, smart farming. So what is smart in the sense, right? What is smart? That is very important. How smart the farming should be, right? So the word smart itself has so many things to justify, right? So the notion of smartness talks about handling the data without humans, right? In the absence of humans, handling the data and storage of that data, right? Sensing the data continuously in the absence of humans and storing that data. And once the data got stored, the storage is very much required because whenever the original data is required for the sake of comparison at a later point of time. The stored data is very much useful, right? So once the data got stored, then the data must be forwarded for the downstream tasks like machine learning, like decision making, right? So yes, these things they talk about smart, right? These aspects talk about smart, and we attach our problem of problem under consideration to the word smart to solve or to perform all those tasks. So smart farming involves sensors, storage capabilities, right? And also the decision making capabilities. Before decision making, of course, actuators involved, and these actuators they perform actions, right, through decisions that the machine or the application will take, right? So as on date, there are so many prototypes available. These prototypes should move towards end products, usable end products for the population at large. So the domain here we are discussing is farming. So farming prototypes should go towards products. That's what the interest is all about, right? So this slide is asking an important question called, can technology be the answer? Yes, of course, technology helps to solve the issues in farming, right? So here, whenever technology answers the problem, we need to move towards selecting a viable technology to solve the problem, right? If you observe carefully, this talks about optimization. The slide, the information present in the slide is all about optimization, right? So what you want to do, your objective is what? You want to maximize the profit with what constraints? With lesser input, right? Higher output with lesser input is your objective function with that, of course, with that constraint. Lesser input is the constraint that we have. So today we see food security is almost a is left from our hands, because if you carefully observe nowadays, no food is no food is what is a genuine, in the sense all majority of the food items got adulterated, right? So if the food that got adulterated, and also we have listened that rice, some percentage of rice is combined with the plastic rice, right? How danger it is when it is used in the household, right? So population is ever increasing, but the resources and the crop yield is theoretically said to be maximized. Objective, we are objectifying it, we are saying it as an objective that we need to realize, but that objective is actually realized or not is the big question, right? So we have inputs like soil and water, fertilizer, right? Pesticides or herbicides. We have machinery, manpower, right? Everything are serving as inputs here. So these inputs should yield higher output for us. The output is the yield, maximum profits. The profits should be for the farmers, right? And the crop yield should be maximum. So there are so many factors that decide the crop yield, right? So we are not going to that aspect as of now. We would like to select the technology for handling this issue. So there are classic versus modern responses available to solve this problem, right? So we concentrate on modern response. So instead of working with bigger machines, you work with smart machines, right? You work with smart machines, and we are now in the data age. We are now in the data driven solution age, right? So we need huge amount of data. So that data, when analyzed through various techniques and technologies, of course, it gets converted to useful information, right? So the hot areas that support this task is digital agriculture, data analysis, machine learning, right? Autonomous systems and AI, right? So this slide shows up for different farming activities, right? What are the different technologies that are adopted, right? You see vertical farming, urban agriculture, right? And you see UAVs, you see unmanned aerial vehicles. So there are drones here. Drones are monitoring the field, agricultural field, in the absence of human being and sending the critical and useful information, right? Then you see automated agriculture through robotics, right? So a person might not be, need not, strictly speaking, need not be available in the agricultural field. The person is available at remote location. Still, the person can remotely monitor and operate his or her field, agricultural field. To that extent, today we are seeing the benefits, right, through technology by monitoring and reaping the benefits of harvest. Right. So agricultural 4.0 as industry 4.0, we are already discussing today. Not much of the persons, few people they are discussing about industry 5.0. Of course, agriculture 4.0 we are talking about. So in agriculture 4.0 we have these technologies available, right? So agricultural robotics, deep learning, wireless sensor networks, big data, IoT, unmanned aerial vehicles, right? So these are the things that one can utilize to realize the objective, right? Realize the optimization criteria that we have discussed earlier. So these technologies and these techniques use and doing farming through these things is called as digital farming, right? So you see, majority of the people they think that VR means usage of head-mounted displays, right, to explore the environment, virtual environment. Of course, device is needed for understanding, for gaining knowledge, for the sake of education, head-mounted display. But VR, the aim of the VR is different, right? Aim of the VR is to trick the senses of the human being, right? To what extent we will see, right? So when human senses get tricked, humans will believe that yes, that particular feedback is felt by me only, right? So if that situation can be obtained, so your senses, we are successful in fooling the senses, right? So yes, VR aim is to, in a very simple way to say, to fool the senses in a successful manner. So how we do that, we will see, right? You see, there are applications today in AR and VR, right, for agriculture. So we will understand few of them as we go on, right? So in order to enter into the VR, so you see there are two screenshots that are placed in this slide. So the left top screenshot, the person is holding controllers and the person is playing a game through VR, head-mounted display and controllers, right? So you see this is a picture-in-picture screenshot that you are observing here. So the large screenshot shows the usage of real hands, right, to touch the environment, gaming environment, and actually the real hands they will get mapped to the what the input devices that the person has held, right? So once this mapping takes place from real to input devices, then the next step is what? The next step is working on the app, right? Working on the app. So that app, as yesterday the speaker has shown you how physics, right, comes into picture and how the concepts of physics make the app VR app more realistic, right? So this must be the environment must be so realistic that the user should get immersed into the app, immersed into that environment and feel that that person is actually present in that environment. So the feeling of presence is very important here, right? Below on the bottom, you see the person is driving a car virtually, right? Through a VR app, right? Whenever the head is rotated, right? So there will be a tracker in the head mounted display. So head movements, head positions will be tracked continuously. Accordingly, the view changes in the virtual world, right? So based on that, uh, when if you are using, if the person is using IO controllers, so those IO controllers are helpful to uh, drive in that virtual environment in a better manner and in a careful way, right? So these are some of the successful applications that you are seeing on the screen. So you see almost all the persons, all the persons, that is all the persons, they have placed head mounted display, right? And they are immersed into that particular environment. So the why I am saying they have immersed, because you see there is an important feedback that you can observe from these, from their faces, right? Can anyone tell that what is the feedback that you are seeing from their faces? No issue. If it is wrong also, there is no problem, right? What is the feedback that you see? The emotional aspect, right? So they are happy, they are immersed, they are connected, right, to that particular app. They are following the instructions, what the app is saying to them, right? And they are working with that environment, working in that environment, right? So person is playing piano. Let us say they are learning the piano. Yes, it is in a virtual manner. Physical piano is not available in front of them. Still they are playing that piano. And you see in the bottom of this slide, you see the physical movements are mapped to the robotic movements, right? The hand movements of the hands of the robot are mapping with the movements of the human being, right? So this aspect we can treat it as training the robot, right? We can treat them as training the robot. So yes, somebody has asked some question, let us say. Okay. So let us continue, right? So So from the earlier slide, we have seen these things. What are those? Head-mounted display device. For some of them, headphone is also attached. For some of the head-mounted displays, headphone is also there. And you are seeing virtual environments, right? And interaction with that virtual environment using IO controllers and the simulation. Right? These are the things we have observed from the earlier slide. As I've already answered the important question, right? We generally move away by seeing that slide is that overlooked point called immersion, right? You see, so this immersion is the outcome of captivation to real-time computer simulation. You see, this com- virtual reality is a course for which the prerequisite is computer graphics. So if you know computer graphics, uh, you will understand in both technology way as well as the end user way in a better manner. So this is immersion. This is called as immersion, the sense of presence. The person feel that he or she is present in that virtual world, right? When that feeling arises, when that feeling arises only when senses will get fooled, right? So you see, happiness, imagination, enthusiasm, calmness are observed in the facial expressions. In the previous slide that you have seen, these are the things that we have observed, right? So VR is at the intersection of interaction and immersion, meaning VR, when you are using VR apps, you are actually interacting with that environment, virtual environment, and you will get immersed into the virtual environment. So you see, these are the applications for interaction and immersion, as you see. So VR works both with 3D models and the virtual environments in which those 3D models actually do certain activities and actions, right? So one point of caution is VR is not really presence, right? It is not augmented reality. If VR is augmented reality, so we will not see another topic called AR, right? So this confusion exists for a beginner. They feel that VR and AR both are same, but actually they are different, right? So VR is not a device. So please make sure that if anybody talks about VR, it is not a device. Device is only uh, what is a thing that is helpful for understanding the virtual environment, right? So we need a purposeful definition and functional definition for VR, which we are going to see in upcoming slides, right? So this is very important. As I told you, uh, you can trick mind at any point in time. You can trick the mind, but it is very tough to trick the senses. Understood, right? So mind does the processing of information it gets from the senses and forms perception of reality. As you see in the image, right? One person says that digit is 6, the other person says it has a 9. So it is showing two different perceptions, right? Yes, no one is no one is right and no one is wrong. Please understand from this image, uh, until and unless fact is understood, no one is right and no one is wrong in perception of reality, right? Now this is another example. This is a very famous image that we see across web, right? So how the reality is shown in a different way, right? Of course, it is not real. It is fake. So who is the victim is only known once you see the real environment. Once you understand real environment, right? Now, so our goal is to alter the perception of reality, right? The goal is to alter the perception of reality. It is possible to do with mind. So we see hypnosis. Hypnosis is a approach through which mind can be altered, right? But this hypnosis is a delicate and susceptible. It is a problematic approach because your mind is susceptible to all sorts of interference when a person is under hypnosis, right? So these methods will lead to adverse effects on the human being, but uh, it should happen in a controlled and supervised manner, hypnosis, to trick the mind, right? But virtual reality takes another approach. It takes it aims to trick the senses, not the mind, right? So you see, tricking the senses to alter perception of reality. The person is sitting here on the land, on the earth, let us say, as person is sitting on the earth wearing head-mounted display, and he virtually landed on the moon, right, through Apollo 11 mission. So this Apollo 11 mission is a virtual app, VR app, which maps real person with a virtual avatar. Right? We can say them as avatars, right? Avatars are there in both VR and AR, right? So what is actually happening when person lands on the moon? View through let us say with the help of this rocket, right? So whenever the person is observing the environment, environment surrounding the moon, and when the rocket launches on the moon, the person should experience the sound, vibrations, right? And the what is it? The various physical aspects, inertia and anti-gravity. All those things must be experienced when the person comes out of that particular rocket and rocket and land and keeps the feet on the moon, right? So these things should target only the senses, right? When these things target senses, then it is understood that yes, person is feeling that environment, right? Person is feeling that environment. So that targeting the senses is through artificial computer generated stimulus. So we see majority of the people, they have with them the iPhones, right? So in iPhones, there is a feature called haptic feedback. So you might have sensed the vibrations that the application releases whenever you uh, whenever you activate that feature in your iPhone, right? So whenever you send a message, right, whenever something is received to the phone, right? So that feedback, haptic feedback, that vibration you might have felt, right? So there your sense has understood that some feedback in terms of some electric impulses, right? We cannot say directly that it is an electric impulse until and unless you wear a suit, haptic suit, and you perform some activity in the virtual environment, right? Which sends a electric signal, electric impulse as a response. So tricking senses, as I told you, tricking senses is much harder than tricking the mind, right? So mind is capable of filling the blanks, but senses will easily distinguish minute differences. This is very important, right? In that case, at that level, if I understand, if everybody understands this, senses can understand the illusion, right? But that illusion should be in a controlled way. As you see, the achievable goal is creating a believable experience. Please underline this. What is a phrase which says creating a believable experience, right, through artificial stimulus. So that experience is should be good enough to prompt the mind and the senses that yes, it has been felt, right? So now comes the functional definition of and the usable definition of VR. So VR is a high-end user computer interface that involves real-time stimulation and interactions. Real-time simulation and interactions through multiple sensorial channels, right? So what are the channels? Various sensorial channels that are we have: visual, auditory, tactile, smell, and taste, right? So I think few people here have already experienced 4D, right? 4D movie might have gone to for some 4D movies and experienced the 4D, right? So there you see visual, auditory, and what do you say, tactile responses, right? That is mapped with the scene that you see in the movie, right? Your seats will vibrate. Your seats will vibrate here and there, right? When when scene is happening there. So there is an actual mapping here with virtual movie scene, and with the real world environment. So that mapping helps understand the that mapping helps trick the senses and make the experience more lively. So smell olfactory sensors will be there in our notes. These olfactory, the engineering these olfactory sensors is not that easy. There should be some array of sensors which are to be configured, and these array of sensors should be uh, should only sense certain what it says the aromas, some smells, right? So it is. Is my voice reachable?
Yes, sir.
Okay, fine. Okay, right. So engineering olfactory sensors is a challenging thing. So that's very important, right? So visual, auditory, and tactile we are seeing through our devices. We are feeling through our devices, but engineering smell and taste is a very important thing, right? It is challenging and it is interesting also, right? Now the goal of VR is to create a perfect illusion, an artificial experience which is so realistic, right? That is practically un, indistinguishable of the real world, right? So now what I do before continuing towards the uh, use case scenario of AR and VR. So few people have already installed, most of the people have already installed apps on their smartphones. So you see, Farm VR is an app uh, which helps us learn, understand, getting educated how farming is done, right, through VR. So let me show you the head mounted display that is available with me, right? So let me switch on my camera. So I hope the head mounted display is visible to the audience, right? So is the device visible, madam?
No, sir.
No, no, 1 minute.
Yeah.
I have switched on my camera. 1 minute, I'm stopping the share. Now I think the camera is visible, right?
Yes, sir. It's visible.
So please excuse me for the quality, the camera quality that I have in my laptop. So this is the head-mounted display. This is what is a budgeted head-mounted display, let us say. So you can actually purchase with the 2000 and 3000 by using with that amount you can purchase through online Amazon, right? So this head-mounted display comes with this what you say, the holder for holding the smartphone, right? So you should start the app, you should start the VR app in your device, and you should place in your device like this. You should place this phone, smartphone, right, in your device, and you should close the holder, right? You should close the holder. So once you start and close or hold the smartphone in this head mounted display, you will be seeing lens here, right? You see there are two lenses here. I think is are the lenses visible, madam?
Visible, sir.
Right. So these lenses help us to uh, see the virtual environment in the app, right, in a nearer way. Please understand, in order to experience the immersion by a user, the environment should be nearer, right, nearer to their eyes, right? So this is a device that is useful for uh, educational purposes, right? So if you are really serious in doing some project, you have so many what you say sophisticated VR head-mounted displays available, to which I/O controllers and headphones are also configured. Right, this is a very simple thing. Uh, Sophisticated devices are available. Uh, you purchase the cost is very high. Please understand, the cost is very high. But the facilities that these devices brings in are highly useful, right? So madam, I will simply stop my video, and so
Okay, sir.
somebody has raised the hand. 1 minute. So you have to buy Meta. Okay, Meta Quest. Okay, sir. Low budget VR is cardboard VR. True, sir. Which is developed by Google. Of course, I am with you. But still, uh, when we are when we are exploring the environment through the apps, of course, you can work with cardboard VR. But when you are getting these VR glasses at a low budget, it is better you feel the head mounted display. You feel the head mounted display, so that the the purpose of understanding the concepts will be uh, easily uh, easily realized, right? So Ramon sir, you have raised the hand. Please unmute, sir. You can ask the question. Okay, fine. Let me continue from where I have left. Okay. So the crux of VR is this one. You see the objects in the virtual environment, which are virtual. You will listen to the sounds and voice of other virtual objects in the environment. You feel the sensation of touch, right, with that virtual object, right? All these are available in the virtual environment, right? So when you are able to sense, when you are able to listen, when you are able to see the virtual objects and uh, understand what they are actually, you are actually feeling the presence in that world, in that virtual world. That is called as immersion. So this, when immersion is, when immersion has happened, your senses will actually got fooled. So in order to fool the senses, the physical sense organs will get fooled by engineered sensors, input devices, and output devices. So this is what we need to understand, right? So how, so you might have a doubt. If we are, if the senses are getting fooled, then how this VR helps in learning and in understanding and getting educated, right? So that's where the entire industry is residing, right? Because of this only, humans will better understand what they need to do. So yesterday the speaker has talked about the uh, medical field examples, right? Education in medical field through VR, right? So the operations are performed on the virtual bodies by you through your virtual avatar, right? You will gain experience, you will gain knowledge, you will understand what is correct and what is wrong in performing the operation by you, right? So you will sense the presence of blood flow in the virtual body. You will sense the organs also while interacting with the virtual body. All those things will happen. So you feel that you are actually working, you are actually operating on a human body, right? So let me move from here. So the software development environments play the key role in engineering these VR applications, right? Earlier, there is a World Toolkit, which is a 3D virtual reality development tool. That this development tool is using C++ and C libraries for configuring, interacting with real-time simulations, right? So we have virtual reality toolkit available, right? So uh, this toolkit helps you to reuse the solutions, right, for various requirements and for various applications, right? So the creation process of virtual environments can be when you can be sped, it can be fastened, or let us say not fastened, let us can be speed up through this VR toolkit, right? So this is a VR bowling game, virtual bowling game, right? So this is hosted in this GitHub environment. I will share these links with you. If I will also share this presentation with all the participants also, no issue, right? And this is through Java 3D, right? On top of Java 2D, you should install 3D package, 3D libraries. So these 3D libraries will work, will interact with the 2D Java packages and helps you to build small games like this, right? So in this game, you observe on the right, uh, the robot should enter into enter and exit from those two arches that you see, green arch and red arch, without touching the arch as well as the other robots. Let us say I am only showing you one robot here in this simple demonstration. There will be multiple robots. The thing is, one robot should not touch the other robot. If the robot is successful in moving around these arches without touching other robots and any other things, the score will be high for that robot. So for every robot, as you have seen in your yesterday in uh, what you say in Unity, every 3D mode object in that virtual environment has three x comma y comma z values. That is a three-dimensional object, right? So those values are actually will get updated continuously when the object moves in that environment, right? So, so this is an introduction to VR. The same lines, first we will introduce to AR also, not that extent as you have seen in VR. We will just introduce to AR with the help of definition, right? AR, augmented reality, is an interactive experience of a real world environment where the objects that reside in the real world are enhanced by computer generated perceptual information, right? Sometimes across multiple sensory modalities, including vision, auditory, haptic, soma, sensory, and olfactory, right? So you see the difference between the virtual reality and augmented reality definitions. In augmented reality, you are augmenting the real world with the virtual, right, objects, right, virtual objects, and you are taking the support of that virtual environment to explore the real world. Are you understanding my point? So you see, it is an interactive experience of real world environment. You are simply enhancing the real world with your computer generated information, perceptual information, right? So you will better understand with the application, the AR application that you will see in the upcoming slides. So the goal of AR is to enhance real world with virtual elements in an interactive manner. Right? That is the goal of AR. So how, right? So you will see now. You will see first. You will see that simple example of what is a AR. You see, this is the example of AR, augmented reality. The person is in the grocery store, right? This is the real world, real environment, and person is trying to find certain product because this is a supermarket store. Finding the product of necessity is very tough, right? Where the persons who will guide you are not available. As you see in this scene, there is no person who is guiding, who is helping the consumer to find the product. So the person is using the facility of augmented reality AR to head mounted display, and the person is trying to find the needed product, right? Grocery shopping reimagined with AR and VR, right? So you see, this computer generated information, perceptual information is added to the real world, right? This is augmented reality, right? So we will see some more examples of AR. First we will come back to this uh, simulation of real world simulation, right, for haptic and VR. So here the aim is to do harvesting through agricultural robotics, right? So fruit crop harvesting. So you see there is a servo control, visual servo control available. So this visual servo control is responsible to find out the fruit, we visualize the fruit first through computer vision capabilities, right? Understand the ripened state of the fruit, right? And pluck those fruits and send them to the bin to collect those fruits, right? So in real world, the agricultural field is not limited to a one plant or one tree as you see in this simple slide, right? So when you move forward, you see the agricultural field looks is with multiple trees and plants, each each having multiple fruits to pluck, right? To to perform harvesting, right? So the real challenge lies here for the uh, hand, virtual hand, as you see this robotic hand, to extend to that location and observe that fruit first, right? So the fruits are available in multiple locations, and it is the requirement of the arm to rotate also. Rotate there are limitations for the rotation. The joints that are visible in that robotic arm manipulator have got limited limitations in terms of rotation. So based on the limitations, the movement should be what to say fine tuned in that robotic arm, right? So you as you see the actual and the simulated uh, what to say robotic arm servo control is visible here, right? So the environment is also simulated. The what real environment is simulated, and there is a conveyor belt as you are seeing here. On the conveyor belt, the plucked fruit is kept on the conveyor belt, and that fruit goes and directly enters into the bin, right? So as you see, the different movements of the robotic arm for finding and plucking the fruits from different location, different heights are shown in the below images, right? So this is the field. In this field, which is completely filled with, thickened with so many trees, with so many fruits, it becomes a challenge for the robotic vision and arm to successfully pick up all the fruits, right? So these are understood as complex dynamics. Right? These are understood as complex dynamics because a regular way of finding and picking up is not present here. Right? It is associated with multiple movements, arm movements, and that to constrained. The movements are constrained, and end effector is is selected in such a way that it should only it should pick that fruit and should place on the what is a conveyor belt, right? So now we see how the real hand is mapped onto the robotic virtual hand, right? You see, these are the environments. At that point of time, they have used MATLAB for vision, microcontrollers. They are ROS real time operating system. They have used. They have used packages called VREP, and they have used different sensors, right, for the sake of vision and for the sake of distance, calculating the distance, right? So yes, so these are the steps that we are seeing in order to create virtual hand. So first, we are using VREP software to create 3D models of the arm, right? Shoulder, from shoulder till the fingers of the hand, right? So you see how complex it is to visually, what do you say, map or create a 3D model for the various parts of the hand, right? So you see in step two, what is actually happening. So setting positions for gears, joints, and pins, right? So this is very important because uh, once the positions are once the positions are finalized for joints, for gears and pins, these positions help the movement of the robotic arm in a correct manner, right? This should be calibrated. Strictly speaking, the position should be perfectly made so that the movement is in tune with the physical hand movement, right? So step three, yes, that's what I'm saying. The step three is about fine tuning, right? Setting correct axis for the joints and members of the joints. And the fourth step is very important, building inverse kinematic tasks for the arm and each fingers. What is inverse kinematics? Inverse kinematics is, can anybody tell me what is inverse kinematics? Yes, please. So inverse kinematics is about moving from end position, desired position, right? Moving from desired position, given desired position, right? So with the joint angles are computed continuously, right? The end effector, as you see, it moves from current location to a new location, right? In order to continuously pick the fruit, right? And it should also rotate, right? So this rotation is only possible through joint angles, right? So inverse kinematics says that it is required to compute the joint angles, right? To place an end effector at a desired position and orientation. So this is very tough because tough in the sense there are simulators available, there are softwares available today, but understanding this and appreciating this concept is very important because if you can map this with the real world real hand of yours, right? We are doing by the virtue of to say nature and the flexibility that we have, right? We are doing those things with ease, but making the robotic arm do that is not that easy, right? Because computing the joint angles continuously and making the end effector position in a correct location is not that easy, right? So once you do inverse kinematics, once you do that, you should adjust simulation by checking the material properties and inertia, concept of inertia uh, for realistic effects. Because sometimes the thing what happens here is when you move the hand, if the simulation is not correct after making after real the real in the real world, if the hand has been moved to the desired location, only after that the virtual hand is moving, that does not have any sense. Your virtual hand should move, and strictly speaking it must move with your real hand movement, right? It should move accordingly. It should move in when the real world moves, right? So it should not. There should not be any lag here in the movement of virtual hand, right? Then you see you perform certain experiments. As I told you, calibrations are very important because it is required for exchanging data between real sensors and simulated sensors. So when you are working with sensors, as of course your simulated sensors and real sensors, but data when it is collected from the real sensors, right? They should map onto the virtual sensors, right? So you see, when sensors are equipped in that virtual hand, the real world sensors will also um, make the communication more clear, right? And hand movements and communication more clear. So finally, if you observe, this artificial arm in the simulation world will actually respond to the operator's hand in the real world. As I told you, this must be without any lag. This must be without any lag. In which direction the arm is moving, the simulated arm also should move in the same direction in the at the same time, right? So your field can be created virtually, right? Through vision, right? Vision concepts like leader or photogrammetry, right? So you are viewing your trees in the field, right? As 3D models, right? As 3D models. And please understand, uh, you every tree, every what you say, the branches of the tree and the leaves that are present in the tree, they are uncountable. They are infinitely countable. Let us say, strictly saying, let us say infinitely countable, right? So making them into a 3D model and counting every leaf for the sake of graphics manipulation lead to high requirement of resources. So there should be techniques, there should be adoption of certain techniques available to view a high, high, highly, what to say, resourceful 3D model, right? In terms of geometry, you see, computer graphics treat the 3D model first initially as a geometrical model. So geometry, what kind, how, if you treat the leaves in terms of triangles, how many triangles are there? If you treat the entire tree as a triangle, how how finally you count so many number of triangles. So manipulating those many number of triangles is not that easy using graphics, right? You should adopt certain techniques so that whenever the virtual camera is moving around in the virtual environment in the field, right? So if it is moving from a particular tree to a certain distance, the level of detail of that particular tree should come down. So there way what happens, the number of triangles that you are computing, that you are working on with, will come down. When you move far away, when you move far away with a predefined distance, that tree should get invisible, should not be in the sight, camera sight, right? So you should maintain different levels of detail of the 3D model, right? So that these 3D models, when they are storing in the database, they should dynamically enter into the scene based on the distance calculation from the camera. So the depth is very important in this scenario, right? Now, this virtual orchard, you see, this is now no different from the real orchard, real field, right? So if your visual, if your virtual scenes are this clear, this clear, right? So the level of immersion will be very high, right? This also plays a crucial role. If the scenes that you prepare, 3D scenes that you prepare, are not that high, are not that clarity or that quality, then your vision also, the eyes will also, what you say, will become victim of that virtual environment, right? So you should find out how better the VR environment is, right? For the sake of vision, because you are viewing the environment at a nearer distance, right? So today you can create the content, virtual reality content, and explore that content with the help of deep learning. So this is a review. This hierarchy, this taxonomy I have taken from a review paper, right? So it's a deep content creation, deep content analysis, deep contactless interaction, right? Deep content manipulation. So there are so many things that you can actually have in terms of creation and exploration, right? So few things I am showing here. So your scene should be panoramic. Please understand, your virtual scene must be panoramic. So to make the panoramic scenes, right, you can take the support of video stitching, right? As you are seeing in the left top, with the help of video stitching, you can create panoramic views, which is in toto, which is complete, right? So view is not what you say, incomplete in terms of understanding the scene. The view is now complete with the help of stitching, video stitching. So it is possible through the deep learning architectures available for computer vision, right? So you also have 3D modeling of an input image of a face, how an input 2D image is moving ahead to create a 3D model by following the sequence of steps: input, reconstruction, geometry, right? Skin reflectance, illumination, and finally 3D model is being formed here, right? So that's why today purchasing 3D model, a 3D model is not is heavy. It is the price of a 3D model is high, right? So there are only few. There are very less 3D models that are available for free, and those 3D models does not match with the quality of a 3D model for the sake of virtual environment, right? On right, you are seeing a virtual space where the table and the almirah is available, upon which objects are actually added at a later point of time. You see, there is a virtual chair, there is a virtual flower vase, right? There are virtual kitchenwares that are placed inside that particular stack, right? So you are filling the scene with virtual objects. Please understand, to make it realistic. And also, the most interesting thing that you are seeing in this particular scene is the shadow, right? Yesterday, I am continuously recalling the yesterday speaker because so the aspects that the speaker has covered are very important, and that those aspects I I have seen such a speaker for the first time who has given information inputs in a very what you say uh, what is interesting manner and very slowly, right? So that every information is reached to every person in the meeting. So that I liked very much. So yesterday or day before yesterday, the speaker has told that light is very important for 3D and 3D modeling, right? For 3D analysis and 3D modeling for virtual, for VR, right? So the light is implicit in VR apps, and you see the shadow. Casting a shadow is very important to make the scene more realistic. There are so many algorithms available out there for casting such shadows, right? So why I am revisiting this definition? So because to make this understanding, right? To make this example understandable. So that's why I revisited the definition. So the previous taxonomy is about uh, the software aspect for VR, and this taxonomy is for AR deployment. This is hardware, right? This is hardware view for AR, right? So view based and triggered, what do you say, AR devices, AR applications for the sake of these devices are available. So quickly, if you see, so for various applications, what are the integrated technologies that are available through AR, right? So you see AR cow tracker application. So AR cow tracker application requires GPS and machine learning technologies to be used, right? So crop disease identification is specifically, it only requires online database, right? For autonomous machines, platform to control autonomous machines is very much required. Not only that, the GPS as well as the network infrastructure is required, right? So this slide helps you better understand what are the technologies useful, what combinations of these technologies are useful to realize a particular AR application, right? So this is your, let us say this is your field, right? Agricultural field. You are using AR to navigate in your field, and you are moving around that field and finding the information, right? So the most important thing, whenever you are doing augmented reality, whenever you are performing AR based data analysis, right? So there, the GPS and GNSS are very important. What is GNS? GNSS, Global Network Satellite System. I hope that is the definition of that is the full form of GNSS. So Global Network Satellite System. So you will see that GNSS in upcoming slides. So you see, you enhancing the real environment with this virtual information helps the beginner or the first time visitor of the field to navigate that agricultural field in a better manner, because uh, the fields often associated with unknown visitors, right? Like snakes and other harmful creatures. They are said to be harmful only when we try to create harm to them. But of course, they are harmful at any way, at any point in time. So, moving and exploring the field in a better manner is through this AR, right? Augmented reality. So, this is the application like fence, like stock, right? Livestock monitoring is one application that you are going to see now. This is the application where every cow is numbered with a unique number, right? To in order to identify uh, different cows, right? Uh, you see, this application is bounding a box by identifying cow number 22, and it is also showing you estimated consumption by that particular cow, right? So, and it is also informing you movement per week compared with the rest of the herd, compared to the rest of the herd, what is the movement of this cow, right? So, this crucial information is very helpful for the monitoring person, this livestock monitoring person, to take necessary steps and to help to provide better what to say um, support to the stock, right? To make it healthy. If at all the indications, the indicators are showing up most problematic information, still the monitor, the person who is monitoring the stock can solve the problem, right? Clearly for a particular cow, right? So the target cow is behind another cow. Please walk closer so that the target cow is visible, right? So it is asking the person to come forward so that the visibility of that particular cow is clear, right? So this kind of information is very useful through AR, right? So this is augmented reality, right? Then we see when AR and VR are there, as I told you, XR is coming up. XR farming is no longer a myth. We are observing and we are feeling that today, right? So world population projected to reach 9 billion by 2050. Expect agricultural consumption to increase by nearly 70%. So if in these situations, so the sustainable goal that is announced that there are so many sustainable goals available announced by the UN. The second sustainable goal is hunger should be zero by 2030, right? So through how technology paces towards realizing this particular what you say goal is is to be understood only when time passes by, right? Now, this is another application of AR where the person needs to pick up soil samples from the particular region. So somebody has uh, given a message. Yes, please, I will share this slide. No problem. So as you see, there are so many regions available in a particular field called Rasi. As you are seeing, Rasi is a name of the field. There are, let us say, so 8 fields. Let us suppose there are 8 fields in this particular regions in this field, and across these 8 regions, the the person who is navigating this field should collect soil samples for the sake of analysis, right? So as you see the steps in the left, top left, you see, so you you are collecting the images of the regions through your AR, and you are sending the soil images regions to the algorithm. So that algorithm, what it is doing, it is helping the user to find out the soil samples which are to be collected correctly across these 8 regions, and how many samples are there in every region is also shown here. Also, here, as you see in every slide, in every screen you are seeing, there are 8 regions. How many samples have been collected? You are seeing the status also, right? And this is through AR. So augmented reality helps to find out correct soil, correct soil to be what do you say used for the sake of analysis and draw some crucial insights, right? So the hardware is like this for the sake of augmented reality. So here you see there are 3 different types of architectures, hardware architectures available for AR. So one is talking about graphic system, the second is talking about monitors and head trackers, and the third one is talking about head tracker in which scene is getting generated, scene generators. So how the scene get generated? The scenes will be downloaded from the database, right? In the in the view itself, the scenes will get downloaded, and those scenes will be made available for the user to interact, right? So head tracker helps you to do that. So what could be the scenes based on the field, so what kind of virtual what to say computer generated uh, content should be augmented onto the real world. So you can select from that app, and you can download it and you can use them, right? So the device looks like this. So AR device, this is also head mounted display device. So this is an industry level device, right? Industrial device that they use for the sake of doing field work, right? And these are the various applications for which the type of AR devices that you can use, right? Actually, right? For livestock, as you see, mobile phone is enough. Wearable smart glasses are actually enough, right? Then for crop disease identification, for crop information overlay and viticulture digitalization, you can use mobile phone, right? For real time information about autonomous machines, yes, you can use wearable smart glasses, right? So to control machines, those autonomous machines. So yes, these are the monitor based, as you are seen in the earlier slide, monitor based architectures, optical see-through architectures, video see-through architectures are used for different subdomains of the agriculture. So how AI? Today the field is AI, right? And today everybody is using AI today, and AI is and has entered into every field, almost every field, right? So using AI in AR and VR, right, it enhances the experience in multiple ways. So it advances and personalizes the user experience. It fosters efficient interaction between user and technology, right? So it also improves quality of the content. Of course, we have seen deep learning example earlier, deep learning taxonomy. So you have seen how content, the images have been developed with quality, high quality, right? So now coming to XR, right? XR is the combination, is a collective term that combines augmented reality, mixed reality, and virtual reality, right? So we have seen AR and VR. What is MR? MR is user interacts with responsive virtual elements integrated to the real environment, right? So in augmented reality, the information, the digital information that you augment to the real world is static. It is not responsive. But in mixed reality, the virtual information that you augment onto the real world is responsive, right? So it is integrated with the real environment for the sake of response, right? Then, so XR in agriculture, so many benefits it reaps, right? You see to the left, VR simulations for insurance companies, government planners, right? What simulations are useful there? What simulations are helpful for insurance company? Droughts, floods, pests, and outbreaks, right? And also, VR simulators are useful to train farmers and students on tractor and drone operation, harvesting and post-harvest handling, greenhouse management, right? Safe learning without crop loss. So these are the uses with VR. AR guides overlay step-by-step repair instructions on tractors, harvests, and pumps. This is very much useful in Indian context, right? So majority of the time, the farmers face difficulties in solving the problems in solving the repairs that they see that they have with their tractors, right? With their pumps, harvesting pumps, right? So it reduces downtime and dependence on external technicians. So a augmented reality helps them to repair their tractors on their own, pumps on their own, right? XR and plus AI helps visualize disease patterns, spread patterns, yield forecasts, pest life, pest life cycle simulations, right? So this makes the farmers understand the cause and effect, but not just alerts, right? So this is very important, right? So because of what is the cause that has led to this particular issue, right? This particular disease spread, this particular pest, right? So that talks about the yield of the crop, right? And also, interestingly, digital twin is very much useful, right? When you build a digital twin for the real world replica of the real agricultural field, it helps simulate weather impact, optimize greenhouse climate controls, right? It also helps in testing crop rotation strategies, right? So instead of directly entering into the field and changing the crop in your agricultural field, you can first do it virtually. You can do it virtually in the digital twin, and the responses that the digital twin gives you can be taken into consideration, and you can what you say uh, through your intelligence and wisdom, you can plan for a better crop for better yield, right? So this XR also fits in Vikasit Bharat 2047 goals, right? 2047 goal. There are so many goals under Vikasit Bharat. Make the country substance free, make the country agriculturally strong, right? So low literacy barriers. So the farmer, today's farmer has intelligence and knowledge regarding how to work in the field and how to maintain their field, right? Uh, Still, yes, literacy is still a challenge that is available, but through VR and XR, through VR and MR, that is the XR, this barrier, literacy barrier, can be overcome easily, right? Just it is through visualization. So image speaks more than words is the phrase that we know, right? So obviously, visual learning is better, more, but is better than the what you say words, normal words, right? Here we are also virtual reality also uh, scales better when normal text is associated with images, audio, and video. Right? Virtual with IoT, drones, and AI scales from small farmers to smart agribusiness. So XR is helpful. Now, please understand in this entire discussion, your virtual reality and augmented reality, they are integrated with what today's machine learning and deep learning concepts for making data driven decisions, for drawing data driven decisions, right? So this data driven decision making is when integrated with this kind of XR and AR VR environments, it gives you it gives you results that are multiple fold, right, in a better manner. So the demand, this is very important, right? We the one side of the coin we have discussed. The other side of the coin is, are skilled professionals are available across the globe and particularly in India for AR and VR? That's the important question, right? So in India, we take the statistics projected for Indian context. So India's augmented reality and virtual reality sector is set to exhibit 14.63% of CAGR, right, by 2027. You see, with an huge requirement of 1400%. So this is not a small thing to say leave aside, ignore, right? 1400% upsurge is showing for AR VR engineers. So this is a quite interesting and important field. So the my sincere suggestion and my sincere points that I would like to highlight here is, students, please motivate students to do projects of, whether it will be simple project, it could be a mega what to say a moderate project to a high level project. They need to do projects in VR and AR. So it is interesting for the students because it is a gaming platform as such, right? So they develop apps as in the form of games. They treat them as games, right? So when they develop these apps as games, right, it reaches to the audience to a great extent. That content reaches to the audience great extent, and of course these things will motivate peer learners to gain expertise into this field of VR and AR, right? So quickly I'm moving to the next slide. So this is what I told earlier. This is the sustainable development goal by 2030. There should be mm, there should be zero hunger across the globe. But there are so many practical what is it, challenges in this path to handle, right? So if you visit this website, the website that I'm showing below, and the URL link that is shown adjacent to you, you will better understand this particular image, right, about path to zero hunger by 2030. And you can contribute to this. You can give an attempt to solve the problem by we you with the percentage, with the amount of contribution percentage from your side. And finally, so these are the uh, VR 3D models as you see in computer. So uh, this is a model, 3D model. So the top left you are seeing is a simple game placing what is it, triangle over the square, right? And you see entire the foundation for this entire thing is once again a triangle. Once you once to start this simple game, uh, whatever whatever things that are already held in this, they will fall down, right? Obviously, they will fall down. This is, you see the concept of physics in action in this particular uh, VR game, simple game. So on top right, you are seeing appending a 3D object, augmenting a 3D object to a virtual scene, right? So this a kind of VR, right? This is a kind of VR. Uh, this is a static scene, right? A 3D model in a virtual scene, right? And below left, below you are seeing a car dropping vertically, right? In the real world. This is in the this is real world. So right side you see a car has been dropped behind me, right? This is the real scene. This is the real environment. A virtual object has been added to the scene. This is augmentation. So there are there are 3D viewers available, right, across your web, and your Windows 10 operating system also helps you work with 3D objects, right? You can play around with this 3D library, and you see there is a toggle button showing you mixed reality being on, right? So finally, my point is, yes, technology, the virtual reality, augmented reality, and extended reality technologies help solve the problem of alleviating the hunger across the globe, right? In addition, not when this AR, VR, and XR technologies are integrated with the machine learning and deep learning aspects, you will see wonders. You will, you can come up with various solutions. The floor is open to think. Uh, there is no point of what you say holding back. Your imagination can be there is no other, yes, your imagination can go anywhere, right? So though that imagination can be converted into a usable solution, right, for the agricultural domain, and solve the problems. Taking small steps and solving the problems will help solve the actual problem. That is my thought process, right? So with this, we have come to an end of the discussion about this topic, and these are the references that are shown here, right? So this is my avatar. Let us say your Samsung phone is available. Some I have my Samsung is Samsung M51 mobile. In that you have a AR app available. Through that AR app, you can create your own avatars, right? So I have added my virtual face to my physical image, right? Physical photo to create an avatar here, right? So this is my simple avatar to the right, you see. So that is augmented to the real world platform bench here, right? On the desk, the avatar is present. That avatar will move also, right? So now now anybody can ask their questions, right? Somebody has asked the important question, right? If we mix LLM tuning with this, your proposed method framework, how it will be? So, yes, sir. So, everything, you should view this virtual environment, AR, VR, as a data generating platform for you, right? So, whatever interactions, whatever actions, whatever feedback that is happening here, right? Everything is recorded in terms of data, right? So that data you should you should use as input for training purposes, whether it could be ML model or DL model, or today you are talking about LLM. So you submit the data to your network, deep network or transformer, or any LLM that you are building from scratch, and come up with the what you say fine tuning, do fine tuning, and come up with a specific what is a solution, right? Of course, it is possible. You can integrate your AR and VR with this LLMs also. That's what I'm saying. The imagination has no bounds. That imagination helps you to integrate. Any other doubts, please? So I think majority of the people have installed the app, right? Can the some of the audience can they confirm in the chat? Yes. So the app name is for this particular demonstration. For now, AR, we talk about AR demonstration. So somebody has asked another question, important question, saying how is to use latest Java technology which can dominate LLM to this VR AR. So Java Vision Java is already available uh, in the what you say in the web. Vision Java models are available. So Java, when you talk about it is joint embedding concept. It is concept of joint embedding. So where it has an edge over LLM, usage of LLM. LLM, what you say, it treats the uh, processing the input data with what you say different tools. It handles to different tools. But the this JEPA joint embedding, what it does, it computes by itself, as far as I know, right? So it is quite easy when compared with LLM, because LLM comes with limited key usage, API key usage, right? I never worked as of now with Japa, but still Japa has got good what you say support, a good edge over LLM. So this can be used in remote medical technology. Obviously, sir, you can use uh, the operations. There are two successful scenarios I can give you, where operations were held from different country, and the operating patient is in India, let us say. So the doctor is sitting all the way in different country, Europe, and the doctor has operated the patient, and the operation has been successful, right? And this happened two times, two scenarios. In two scenarios, the operation was successful. Joint embedding predictive artificial. Thank you, sir, for the full form. So now quickly we will close the session by running the tab, by working on the tab. The app is you we might have installed two apps. Uh, One app is FarmVR. The second app is SimLab VR Viewer. So for this quick demonstration, I request all of you to run through that SimLab VR viewer, right? SimLab VR viewer. So when you have started the app, when you have started the app, you you will see SimLab models available, various SimLab models available. So I hope you are with me, right? Few participants are with me. You have started the SimLab app, right? So the app name SimLab VR Viewer, sir. Is the app's names are given by the madam, right? So, so if you observe this, there are so many SimLab models available. Quickly, the participants are requested to tap on Chair AR, right? Chair AR. So how many are you people with me? May I know? Yes. Uh, okay. So yes, great. So when you have tapped on Chair AR, you are seeing AR mode, 3D mode, right? Below, right? So you simply click on AR option. Click on AR option, right? When you click on AR option, it is saying on the screen you will be seeing a message like this: for best results, please take a look around you and hold the camera steadily. Right? This is what the message you are observing, right? So now what you should do is go to a location where light is abundant. Your tube light should be abundant, right? And place your mobile camera facing downwards, right? Place your mobile camera facing downwards, right? So when you place your mobile camera downwards, you will be seeing ripples, right? Ripples getting on the screen. Can anybody tell this experience? Some people should might have seen the ripples. Is that right? Yes, please. Are you seeing the ripples? Quickly, can anybody give the reply? So when you see those ripples, right? It will it will add a chair, right? It will add a chair after the ripples get stabilized. The virtual chair gets added to this real to your real world, right? You should pay attention. You should have some patience. It will take around 2 to 3 minutes of time to add chair to your environment, right? I hope I hope you have understood the point here, right? So what is actually happening to your real environment? The virtual object is getting augmented. Chair is getting augmented. So this is a simple demonstration that I uh, I have made you to understand about augmented reality in your mobile, right? And the thing is, your Amazon also gives this option, right? How many of you people know that Amazon is for certain products, it will give you the AR flex AR option, AR capability. If you open that particular item in the Amazon through your mobile phone, it allows you to augment that particular product in your real world, right? Your IKEA is doing that today. It allows the user to place that chair or sofa in your location, in your home, in your location, and it allows you to uh, uh, take certain decisions, right? So another question: what are the prerequisites for this topic a learner should learn? The I have mentioned the prerequisite as computer graphics. So computer graphics course the person should take once the person is versed. I say it is not well versed, but versed with the topic, then fine. Then the person can take up this subject virtual reality and do and learn the concepts in a better manner. Thank you, sir. Thank you, Vishwanath, sir, for responding with that app activity. The chair has been placed on the ground. Yes, sir. Thank you, sir. So, with this, I hope I have made some, what do you say, progress in the topic. And I think that people have understood the usage of AR and VR technology, and it has come to our mobile phones. That is the very important thing. Technology is now in your hands, right? Not we are saying this statement, but experiencing the technology, the latest technology in your mobile phone is also an important thing, right? So thank you for your patient listening all through 2 hours, and I think that you people will take up this course and learn the subject in a better way. And I finally the closing point is closing words that am going to tell about this is in IIT Madras we have a VR lab. Sorry, in IIT Hyderabad we have a VR lab. In IIT Madras also there is a haptic lab, haptic lab available. Okay, so mention the course. Uh, may I know which course, madam? It is virtual reality. The course name is virtual reality, right? Email ID I will drop here. VR, yes, VR. Madam, I have
Yes, sir.
completed the session, madam.
Yes, sir. Thank you so much for such a wonderful session, sir.
Thank you, madam. Thank you.
Now I request all the participants to turn on your cameras for the group photograph. Thank you all. You can turn off your cameras. I sincerely thank you, sir, for sharing your valuable insights on the application of VR and AR in agriculture.
Thank you, madam.
Thank you, sir. The session has clearly shown how smart and digital technologies can transform modern farming practices. The discussion on real world challenges and innovative solutions has truly broadened our perspective. So, we also thank all the participants for your active involvement and enthusiasm. So, the feedback link has been shared in the chat box. So, I hope all of you have filled the form. So, we are concluding the session in the next 5 minutes. So, please fill the form.
Madam, may I leave the session?
Yes, sir.
Yes, sir.
Thank you, sir.
Thank you, madam. Thank you.
Thank you, sir. Anta ma'am, shall I end the session?
Okay.
Thank you. Thank you.
Yeah.